All right, take 2 on this recording because Zoom just shut down. All I've said was not a lot of important stuff. Just we're maximizing, we're minimizing. We are always in quadrant 1, so 2 of our constraints are always x is greater than or equal to 0 and y is greater than or equal to 0. So that's all I've done. I previewed this in the last video too, so I got to move on. The next thing we have to do is we are going to take the words in the word problem and put them into the table in order to form sentences, in order to form equations. So I'm not going to read this whole problem to you. I'm sorry. I'm not going to read the whole problem to you, but we're dealing with nutrients in this fertilizer. And I think the only thing we did together yesterday or last class was knowing that we need at least 180 units of nitrogen and 90 units of phosphorus. So that goes in my total column. I need a total of 180 units of nitrogen and I need 90 of phosphorus. It said I need at least that amount, so that means I want more than or equal to. So I have a hard time with greater than and less than personally, so I like to write them as soon as I can or determine them as fast as possible. Next, I'm going to kind of focus on the columns. I'm going to focus on column A for brand A and column B for brand B. In the next couple sentences, it gives me information about those brands. So the first one is talking about brand A. Brand A costs $10 a bag and has 4 units of nitrogen and 1 of phosphorus. So I'm just going to go straight down this column. $10 a bag, that goes in my cost. And I have 4 units of nitrogen and 1 of phosphorus. Okay, cool. Brand B is $5 a bag and has 1 unit of each. So I'm going to do 1 of nitrogen, 1 of phosphorus, $5. I don't like writing things in terms of A and B. I'm going to rename them as X and Y. So I'm going to call this column X and this column Y. And these now make cute little equations for me. So I've got this one right here. My first equation is in terms of nitrogen. So I've got 4x plus, 4x plus 1y equals, or sorry, is greater than or equal to 180. I'm going to color coordinate, so I'm going to write that in green. 4x plus y is greater than or equal 180. The next one is going to be my phosphorus one, so it's going to be 1x plus 1y is greater than or equal to 90. We'll do that in orange. X plus y is greater than or equal to 90. And then the last one, we are actually going to do cost. Normally we don't do this one because it asks me to minimize, but it also in the same breath says that we can only spend at most $800. So we want to spend the least amount, but I also can't spend more than $800. So I am going to graph this one. My cost is going to be less than or equal to $800. And I'm going to do one more equation. We'll make this guy blue. And it'll be 10x plus 5y is less than or equal to 800. I love that Mrs. Weaver sends me notes. No, like every, what'd you say? It says I'll bring his quiz and test up to you. That's how passes should work. I should get a nice note every time someone writes me a pass. Don't you think? Anyway, moving on. We don't have time for this. The last thing we're going to do is the min-max line is like, what's the end goal? The end goal is to minimize the cost. So if I'm going to minimize the cost, I'm going to circle the min, and I'm going to write the cost equation without the 800. My answers are going to help me determine what my cost is. And so my cost is 10x plus 5y. Once I find some intersections and have some x's and y's, I'm going to plug them in order to see which cost is the minimum, is the smallest. Okay, and we do that by graphing lines. So I'm going to graph these lines. You can graph a couple ways. You can find intercepts, or I would rather do like put it in slope-intercept form and graph from there. If you have trouble graphing, let me know. If not, I'm going to kind of speed race through this. So y is greater than or equal to negative 4x plus 180. So I'm going to go graph 180, and I'm going to go down 4 over 1, down 4 over 1. I'm probably going to go by tens on this just in order to keep everything on this graph. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. Okay, that's good. I have to go up to 100, and then I go down 4 over 1. So 180, down 1, 2, 3, 4 over 1. 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 Now I get here, I can only go down 2, so I'm going to go down 2 and over 1/2. 10, 20, 30, 40, 50. That means I'm about at 45. 60, 70, 80, 90, 100. 1, 2, 3, 4. Another way I could have graphed was using my intercepts. So if you graph using your intercepts, and I take my equation, so it's 4x plus y is greater than or equal to 180. To do your intercepts, you just cross off one of the variables. So I essentially pretend 4x doesn't exist. So y equals 180. That's my y-intercept. Same thing with x. I do 4x is equal to 180. If I divide 180 by 4, I would have gotten 45. That doesn't come as naturally to me. I don't know if I just wasn't taught that as often, so I don't do that. But if you want me to talk more about that, I'd be happy to later. I have to write a graph and shade greater than, so I'm going to go everything above this. Okay. Now I got to do my other one. I'm going to do my orange one next. So y is greater than or equal to negative x plus 90. So I'm going to graph 90 and then go down 1 over 1, down 1 over 1. I'm about to intersect. If I zoom in, as I'm going down 1 over 1, down 1 over 1, I'm about to cross the same green point. I'm going to circle it, and this is going to be important in a second because I'm going to want these intersect points. And if it's nice and easy and they intersect cleanly like this, it makes it easier for me in the long run. We keep going down 1 over 1. I go to 90. I can connect the dots. That point of intersection, we're going to write down off to the side because we're going to need it in a minute. 10, 20, 30, 10, 20, 30, 40, 50, 60. So it's 30, 60 is this point of intersection. And again, this one was also greater than, so I need to shade all this greater than side too. Okay, everyone good so far? The last thing I got to do is my blue line. So I'm going to graph that one. Again, I'm going to put it in slope-intercept form and graph from there. So I'm going to minus 10x from both sides and divide by 5. So y is less than or equal to negative 2x plus I think it's 160. I can double check that. Yep, 160. I'm not showing all the work where I minus my 10x and divide by 5, but this is the equation I get. So I have to graph negative 2x plus 160. Let me go 160, negative 2. Oop, there's a point that I intersect at. Oop, there's another one. You see those other 2 points I intersected at? That's at 10 and 140. And then this one's going to be 10, 20, 30, 40, 50, 60, 70, and 20. And it said less than. We cannot spend more than 800, so we're going to shade less than the blue line. Okay, the whole reason we did all of this is because I need to find like where are my possible options. My possible options are where I have green and orange and blue, where I've shaded 3 times. The only place that that is this little triangle right here. This triangle I just traced in black is the only place that I have blue and orange and green for all of those points. What I care about is not all the random points in the middle are the 3, I care about the 3 points of intersection. So those are gonna be the options for me for what my cost could be. So I have the point 10, 140. I'm gonna just write these off to the side. I've got the point 10, 140. I've got the point 30, 60. And I've got the point 70, 20. What I'm going to do next is I'm going to take all of these points and I'm going to plug them in to my cost equation and see which one gives me the least amount of cost. So I'm going to do 10 times 10 plus 5 times 140 and see what that's going to be. I'm going to do 10 times 30 plus 5 times 60 and see what that's going to be. And I'm going to do 10 times 70 plus 5 times 20 and see what that's going to be. Why don't we play it smart? Why don't we do this half of the room to my left, the right side of the room? I want you guys to plug in 10 and 140 and see what you get. I want the left side of the room, my right, everyone over here, I want you to plug in 30 and 60, and I'll plug in 70 and 20. The skill today is not plugging in. If you can't do that, I don't know how you made it here. So we don't need to practice that. When I plugged in 70 and 20, I got 800. What do you guys who plugged in 10 and 140 get? 800 too? What about you guys who did 30 and 60? What did you guys get? 600. Which one should we go with? The 600, right? We want to minimize cost. If I can only spend $600 instead of $800, that's the one I want to do. So my answer is going to be 30, 60. And I'm going to write a sentence. I'm going to say, the company should buy. Wait, what do X and Y mean? What does 30 mean? What does 60 mean? Did I hear it? The brands? Which one's the X brand? Okay. So if I said 30 is X, then that means I need 30 units or 30 pounds or whatever of my A brand. So I'm going to say it should buy 30 units of brand A. And it should also buy 60 units of brand B. Okay. I don't want you to turn your paper over yet, but that's it. The one problem that we might have, and we're going to just do it to check our work, just to practice it, is what if we don't have a nice pretty graph and you don't see the points 10, 140, 70, 20, and 30, 60? If that happens, we're going to have to do an extra step of substitution. Let's try 30, 60. We're going to prove that that point's where they actually intersect. I was super careful with my lines. I was super careful with my points. So I know that that's where they intersect. But on the next problem, we're not going to know, so we're going to do this too. If I don't know what this point of intersection is, I need to figure out what my solution is of my systems if I put the green line and the orange line and see where they intersect. I'm going to take the green and the orange line, and I'm either going to do elimination or substitution, and I'm going to solve to see what my answer is there. And it should be 30, 60 because that's where I found them to intersect. Okay, so let me write them below. 4x plus y equals 180. When you do systems of equations, you don't need inequalities. And then x plus y equals 90. I think that's the one I need to do, right? Yeah, okay. So I'm finding where my green one and my orange one intersect. And again, I'm only doing this to prove that my 30-60 point is right. But on the next problem, we're going to do this because we're not going to know. Remember, systems of equations we solve, we can do elimination or substitution. This is an easy elimination. So I'm just going to make this negative, make that negative, make that negative. And my y's are going to cancel out. 4x minus x is 3x. 180 minus 90 is 90. And then 90 divided by 3 is 30. And that's good, right? Because that's the point we wanted it to be. So again, we're just checking our work. You will not have to do this again unless you don't have nice, pretty clean points. But I'm just giving you the knowledge in case you don't have this. Then I take 30 and I plug it into either equation. I'm going to plug it into the first one. So I'm going to say 30 plus y equals 90. And I'm going to minus 30 from both sides. And that's the point we had a minute ago, right? We had the point 30, 60. If we didn't have them line up nicely, we would have had to do that to also find 10, 140, and 70, 20. But we were careful with our graph, and so we don't. But if we do, you may have to substitute in the future. All right, that's all we're going to do here. You guys ready for the next one? All right, let's keep rolling. Do I need to leave this up for a second? All right, let's look at the next one. All right, this one's talking about a manufacturing factory that has different types of paper grade. Let's just go directly into the chart. So as I read it, I'm going to put it directly into the chart. It says on this one that we need to supply 24 tons of low grade paper, 6 tons of medium grade, and 30 tons of high grade. Okay, so I'm going to do 24 tons of low grade. I'm going to do 6 total tons of medium grade, and put 30 total tons in high grade. So I just matched up my rows and columns. They're all totals, and then they correspond with their low, medium, high. The next line starts talking about factories and what they produce. Factory A produces 8 tons of low grade. Okay, so I'm looking now at my first column, and I'm going to put 8 in the low column. It does 1 medium and 2 high, and it costs $2,000 per day to operate. Okay, now I'm going to do B. B, on the other hand, does 2 tons of low, 1 ton of medium, 8 tons of high, and it costs $4,000 to operate. Now, this is more typical for what we see. There's nothing to plug in down here. I don't have a total cost that we have to be higher than or lower than, so I'm just going to leave it like this. Just cross that box out. Normally, that's what happens. So we'll have one less equation to graph. Okay, can we start writing some equations from that? Remember that we always start with x is greater than or equal to 0, and y is greater than or equal to 0. Those are easy. Get those points down. Then we have to do the other one. So let's do low, medium, high. I'll do low in green, 8x. Again, let's make A be x and B be y. Just keep it consistent. 8x plus 2y. Now, it didn't say at least or at most, but it says it needs to supply 24 tons. I'm going to assume that you would want 24 or more. We don't want less than, we want or more. So let's do greater than or equal to 24. We're going to do shading, so we're not going to do exactly equal. We just don't want less than that. The medium one I'm going to do in this, what am I going to do then? Purple. X plus Y is greater than 6. Greater than or equal to 6, excuse me. And then the high one I'm going to do, and we'll just go blue. And I want 2x plus 8y is greater than or equal to 30. All right. Everyone good with those equations? Okay, before I graph them, let's do my min and max. Am I minimizing or maximizing in this problem? It says minimizing the cost. So I'm going to circle min. And that last row in my column, in my matrix box kind of thing, it says cost equals. So I'm going to use that to make my cost equation. It had 2,000 under column A and 4,000 under column B. So I'm going to say 2,000 X plus 4,000 Y. Again, we don't have to graph that because I don't have like an equal to thing. So I don't know how I would graph that. But I do need to graph my green and purple and blue lines. So let's go graph those. I don't know if I physically said in this class, I don't graph the X is greater than or the Y is greater than because like that's just the quadrant that we have. If I graph that, that'd be more lines and more shading that I don't want to deal with. So I just assume that because I'm in this quadrant, I don't need to graph it. So we don't have to graph those things. All right, I'll just talk my way through graphing these green, purple, and blue. Minus 8x and divide by 2. So y is greater than or equal to negative 4x plus 12. Okay, so I'm going to go to 12 and down 4 over 1. These look like smaller numbers than the last one, so I'm just going to do a unit of 1 on all of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The equation I was just talking about was the green one, and it was y is greater than or equal to negative 4x plus 12. So I'm going to go to 12, down 4 over 1. 1, 2, 3, 4 over 1. And again, this was greater than, so I'm going to shade my green greater than. Everyone doing okay so far? Anyone concerns on what I'm doing? Okay. Either we're hanging in there or we don't care about that. Okay. All right, I'm going to do my purple one now. So x plus y is less than 6. So I get to be y is less than or equal to negative x plus 6. That was an easy one. Suicide. I hope my audio is okay. All right, we'll do 6. Negative x, so down 1 over 1. Oop, there's a point that we intersect at, down 1 over 1. This point is at 2, 1, 2, 3, 4. So 2, 4. That's going to be an important point momentarily. And again, shade above. So let me go get my purple shading above. And then last, I'm gonna do my blue one. This one's not gonna be as nice and pretty, which is why I previewed substitution in the last one, because we're gonna have to do something in order to find this intersect. I'm gonna minus my 2x from both sides, and I'm gonna divide by 8. So 2 divided by 8 is -1/4. That's okay. But then I'm gonna do 30 divided by 8, and that does not come out evenly. That's about 3.75. Which you might say, oh, that's not, you might say that's not too bad of a decimal. It's not too bad of a decimal, but it's not going to be exact enough, so we're going to have to do some extra work. So I'm going to go graph 3.75. So that's about between 3 and 4. 1, 2, 3, 4. So it's in here somewhere. And I'm actually going to find the other point by doing an intercept method. I don't know if I've talked about this with you guys yet, but if you remember back from Algebra 1, we taught you about finding the intercepts. And that means like if I were to like cross off one of the variables, like what would the first variable equal? So like if I got rid of x, my y-intercept would just be y equals 30 divided by 8, which we just found a minute ago, right? That's my 3.75. If you want to find your x-intercept, we can pretend like the y doesn't exist. And so that's like 2x equals 30, which means that my y-intercept would be 15. You heard that before? Maybe it's been a minute. I don't think it's the best way of finding it, but I think in this case, it's going to help me keep a nice-ish graph. So I'm going to go graph 15 on the x-axis, excuse me. And I'm just going to connect my two blue points, the 3.75 and my 15. I'm going to see an intersection, but I'm not going to know that that's for sure. So we're going to have to check it. So when I connect my intercepts, it looks like I've got an intersection right here. However, I cannot assume it's a nice, pretty point, so I'm going to check it with substitution. Again, blue, I've got to do my shading, and that's above. Okay, before we do anything else, let's find out what this intersection point is. It's with my blue and my purple graph. So I need to do substitution or elimination with my blue and purple equations to find out what that point of intersection is. So my blue and purple are these two right here. So I've got x plus y equals 6 and 2x plus 8y equals 30. We can do elimination or we can do substitution. Does anyone have a preference on whether we substitute or eliminate? No preference? We did elimination a minute ago. Let's do an example of substitution. So substitution, I think that's actually the best one in this case, is if I get x or y alone in the first one, then I can just substitute the new expression in. So like, let's say we get y by itself. So I get y equals 6 minus x. I can put 6 minus x in for the y in the second equation. Then that will give me one equation of just x's, and I will be able to solve from there. So 2x plus 8 times 6 minus x equals 30. 2x plus 48 minus 8x equals 30. Combine my like terms and minus 48 from both sides. So I get negative 6x equals negative 18. And then I get 3. Am I moving too fast or are we doing okay? Are you in there? Okay. Now in order to find y, I would substitute this x in here. So y equals 6 minus 3, so y equals 3. Some of you might be like, Miss White, come on, that's what it looked like anyway. Why do we have to do all this work? We didn't know. You can always take a chance. You can always take a risk and be like, well, I'm going to assume this. I don't like to assume things, so I'm going to always show the work, but this is exactly what we thought it might have been. So I have a point of intersection at 3, 3. I also have that intersect that I already found at 2, 4. And I actually have 2 more points. I'm going to zoom out just a little bit. My other 2 points are actually these intercepts right here. The reason is any point that works has to be in both the blue and the purple and the green. The green is kind of the base layer, and all 4 of these points are in the blue and the green and the purple. They're shaded 3 times. Now, so are all the points in here, but we're not going to check all those points. The points that are important that could be minimizing our cost is everything that's on like the edges. So again, all of those points work. We're not going to check all of them. So we have 4 points to check this time. We have 0, 12. We have 2, 4. We have 3, 3. And we have 15, 0. All right, so again, let's kind of divide and conquer. So let's do this. Troy's row, you guys are going to do 0, 12. So plug 0, 12 into your cost. Whitley's row is going to plug 2, 4 in for their cost. Hadley's row is going to plug 3, 3 into their cost. And Valeria's row is going to plug 15, 0 in for their cost. You just have to do one, so help your team out. 2,000 times X plus 4,000 times Y. All right, if you plugged 0, 12 in, you guys have an answer yet? Work out 48,000, I agree with that. If you plugged 2, 4 in, what did you get? Did you say 20,000? I know mine's a little out of order. My bad. You plugged 3, 3 in. Do you guys have an answer yet? 18,000. And those of you that did 15, 0, what'd you get? 30,000. Awesome. Okay. Those are our answers. Those are all right. Now our goal was to minimize our cost. Which answer is the best answer if we're going to minimize our cost? Which point that we plugged in gives us the smallest cost? 3, 3, right? That was the smallest one. 18,000 is the best answer. So my answer here is going to be the 3, 3. Now we got to think about what that means and write a sentence to describe that. 3 was X. What did X represent? Factory A. And Y represented what? Good. I'm going to go one step further and say that they were talking about operating factory A and B daily. So like 3 refers how many days that we want to do this. Last block I said hour, and that's wrong. So if we want to minimize our costs, we want to work at factory A for 3 days, and we want to work factory B for 3 days as well. So I'm going to write something like this. I'm going to say the company should have, I'm going to say factory A work 3 days and factory B work 3 days. If I had more room, I would write to minimize costs or something like that. All right, I know we have just a little bit of time left, but I'm going to do this last one. I may have to go through the bell, but I'm going to do it. And I'm going to assign your 7-5 homework to be due on Tuesday. I know I don't see you at all next week, but I'll at least have it due a day that you have class. So I would follow along with me, and I'm going to film it. So hopefully it goes on YouTube if anyone's going to not watch now and do it later. And this one's easier because there's less equations. The only thing is I did not label your chart. So let's label that. I want it to go like this. I want acres to go first. I want seed cost to go second. I want profit to go last. I want my first column to be potatoes. And I want my second one to be corn. And I want my last one to be total. Last class, I kind of gave them a minute to fill it in, but just for time, we're going to fill this in together. It said he has a field of 70 acres in which he plants potatoes and corns. We're just going to say 1 and 1 for this. It doesn't say we need twice as many potato fields as we need corn fields. It's just kind of whatever works out with the rest of them. There's no special limit to acres, but there are a total of 70 acres. He only has 70 acres, so he cannot farm more than that. So we're going to say less than or equal to. Again, I'm not great with my signs, so sometimes I write them in this chart if I can to keep my brain organized. Next is seed cost. If I read my problem, it says the seed for potato is $20 an acre, so 20 in my seed cost for potatoes and 60 for corn. And it says he set aside $3,000 to spend on seeds. So he can only spend $3,000 on seeds, which again, that's a budget, that's the limit. He cannot go more than that, so it has to be less than or equal to. And then last is profit. It says profit per acre of potatoes is $150. Profit per acre of corn is $50. And then we don't know what his total profit is. We don't have a limit or a cap or anything on that, so we can just cross that out. Now, my question is am I minimizing or maximizing? It says we're finding the optimal solution for the farmer. So are we minimizing his earnings or are we maximizing? Maximizing, right? We want to make the most profit. Again, I'm not a business person, but I know I want to make the most money if we're doing something like this, anything entrepreneurial. I think I really messed that word up, didn't I? We'll just let it go. Don't worry, it's being recorded. Someone will watch it and make fun of me later. Or no one will watch it. That's fine too. All right, gotta write our constraints. What are the 2 constraints we always have? Good. X and Y are greater than or equal to 0. We don't really graph them, so sometimes you forget about them, but there will always be a spot to write them. So make sure that you have a spot ready to write them. My other equations just come from my columns. Let's treat the potato column like it's X and the corn column like it's Y. So I'll do my first equation is orange. I'm going to say X plus Y is less than or equal to 70. Again, I had 1 acre, less than or equal to 70. We don't know how many of each of those. The next equation I'm going to do in purple, and it's my seed cost. So I'm going to say 20x, so 20 for potatoes, plus 60 for corn, 60y, is less than or equal to 3,000. And those are actually the only equations I'm going to graph. The last equation, that last line is profit, and that goes on my maximum minimize line. So I'm going to write my profit is 150. Actually, let me write P equals. I think that's nice. P equals 150x, which is 150 per thing of potatoes, plus 50y, which is 50 for each corn. We just have two lines to graph. We're going to graph them, find their intersects, and see which one gives us the highest profit. Again, I like to put these in slope intercept, so minus x from both sides. Y is less than or equal to negative x plus 70. I'm going to do this unit by 10 as well. So 70, 10, 20, 30, 40, 50, turn those on the line, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So it was 70 down 1 over 1. Down 1 over 1. And this is the first time we graphed one that was less than. So that means I'm shading the little tiny triangle that's close to the origin. Need a smaller highlighter. All right, I'll come back to my graph in a second, but let's get my graphing going for the purple line. So I'm going to do y is less than or equal to a minus 20, and I divided by 60. Ooh, why is that just 6? 20 divided by 60 is 1/3, and it was negative. And then 3,000 divided by 60 is just 50. Oh, nice, perfect. This is great. I'm not even have to do any substitution. So I'm going to graph the line negative 1/3 x plus 50 and see where they intersect. Come over here, 10, 20, 30, 40, 50. Down 1 over 3. Oh, there's my intersection point. Down 1 over 3. Down 1 over 3. Down 1 over 3. Down 1 over 3. Again, I have to shade below because it's less than. I don't have any more lines to graph. So from here, I need to see which points I have to use in order to check what my profit is. I see this one right here where the orange and purple crossed. That's at 10, 20, 30, 10, 20, 30, 40. So 30, 40 is definitely a point I need to check. I also have two more points that are on the axis. Do you see how this point is both in the purple and the orange? That's at 0.50, so I have to check 0.50. And I've got one more point that's also in the orange and the purple, and that's the point 70, 0. All right, so we got to check those. All right, let's do right side of the room. Can you guys check 0.50? Right side of the room, can you guys check 30, 40? And I'll check 70, 0. And then we'll be done with this because we'll know the answer. So again, we're going to our profit. We're doing 150 times x plus 50 times y. So we're checking 0.50. We're checking 30, 40. And I'm checking 70, 0. All right, I got 10,500 for 70, 0. What did you get for 0 and 50? Say again. 250? 250? I think it should be one more 0. 2,500. And then what about 30, 40? What did you get when you plugged in 30, 40? Say again. 6,500. Good. Which one gives me the most profit? 70. Yeah, that's kind of a weird one, but he should plant, the farmer should plant 70 acres of just potatoes. That maximizes his profit. All right, I'm gonna leave that up for a second. I do need to come spray desks. Thank you guys for hanging with me. I know that I took us all the way to the last minute of the bell. Again, 7-5 homework will be due next Tuesday. I see you tomorrow for a little quiz. Gabby, did you have a question? Is that good? Oh, sorry, you can't see it yet.
It's out.
Have a great day. There it goes, Gabby. I was like, I swear it's coming.
Thank you.
Thank you, guys. If you need anything from me, let me know. I gotta stop this recording though. I hope I can stop it. Of course, it's gonna freak out. Hi, Cam. Thank you for getting that made up this morning.
Yep.
Hi, Fisher. Yes. And I didn't email back because I haven't put it in yet. So I'll do that when I do that. Thank you. Bye, Bella. Have a good day. Okay, well, I hope this doesn't die. All right. I'm going to come. I haven't sprayed the desk, y'all, so just hold tight. What's that? Yeah.
On this one, what am I exactly saying? What am I not doing?
So when you are doing the inverse, you need to switch A and B, but B and C stay in the same place. With Good questions. This can be your one day. Yo, wait a second, I'm bringing it down. Yeah. No, no, if you take a check. You gotta do that tomorrow.
Why are you on production again? Oh,
Okay, you have to do one.
all right. That's all we can ask for.
We need to do that. Okay, just put a little. Yeah, we don't have to make that other one after we got it. Yeah, thank you. I did it for your desk. Yeah, I'm so sorry. I talked to the went to their disconnect. Thank you for waiting. Are you from all the people? Uh-huh. You think you're so special? Uh-huh. He's here. Mm-hmm. He's only here for like 2 more days though, so. Mr. Fogel.
Why?
He's having some surgery. Yeah, we got to make sure we think about him and pray for him.